All right, ladies and gentlemen, we're going to start now working on quadratic equations and solving quadratic equations using the quadratic formula. So this is the quadratic formula. You've seen it before, but you need to know that for this course, you will need to memorize this formula. This is the formula you will need to know. So we'll play some videos about it. We'll play songs about it, so it'll help you remember it. Um, and when you apply this quadratic formula, you have to begin with a quadratic that is in the standard form listed here. The standard form is ax squared plus bx plus c equals 0. And that means it says when a equals 0 because if you don't have an x squared term, then you don't use the quadratic formula. So if it's just x squared by itself, you have an applied value of 1 for a. Otherwise, you use the coefficient that is with the x squared. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. We'll do practice on it, so it'll kind of help you remember how to do it. One of the things we have to be able to do when we get to the end of one of these problems is potentially simplify a radical. So we're going to refresh that for you. Remember that if the value inside of a radical or inside of a square root sign has a factor that's a perfect square, then you need to factor out that perfect square and bring the whole number out in front of the radical. So what does that look like? All right, so let's look at this, the square root of 84. The square root of 84 is equal to the square root of 4 times 21, because 4 times 21 is 84. 4 is a perfect square. So you don't ever try to factor this unless you can factor a perfect square. A 1 is not necessary. A 4, a 9, a 16, a 25, a 36, something like that. Those are all perfect squares. So when I factor out this square root of 4, I can then separate this into two separate factors. Take the square root of 4 and get 2. So I have determined that the square root of 84 is equal to 2 times the square root of 21. And this is the appropriate way to state this. So here's the next one, the square root of 54. 54 is a factor of 9, so we can express the area under the radical as 9 times 6. So the square root of 9 times 6. The square root of 9 times the square root of 6 is the same thing as 3 times the square root of 6, since the square root of 9 is 3. So the proper way to state the square root of 54 is to reduce it to 3 times the square root of 6. Okay, our next one is the square root of 125. 125 is the product of 25 and 5. 25 is a perfect square. So if we take the square root of 25 times the square root of 5, which was the same combination, the square root of 25 is 5. So we find that the square root of 125 is equal to 5 times the square root of 5. All right, so let's not get too bogged down in how to do that. These radicals aren't going to be really difficult that you have to do, but you will have to manage some of these radicals. So it's time to start remembering some of those things. Last thing about simplifying radicals is that this might be the format that you would get after you used the quadratic formula. So you'd have a value plus or minus a radical divided by a number. So in this case, I've used 54 again. So I've shown you how this could sit inside of our solution. So we would just do the same thing that we did across the top. We recognize that we can reduce the square root of 54. So we change it into the square root of a perfect square times whatever value would equal 54. Then through our next steps, we recognize that we restate this original equation, or this original number, as negative 12 plus or minus 3 times the square root of 6 over 8. All right, let's go on and talk a little bit about using the quadratic formula. So remember, when we use the quadratic formula, the equation always has to be in standard form. The standard form is printed right here. So clearly this equation is not. So first thing we need to do is subtract 6x from both sides. And then when we add 8 to both sides, we then have 0 left on this side. 8 plus negative 8 gives us 0. So that's how we get these equations into the format that we need. So now, if this is the equation, this is in the correct format, so now we can pull off the values for A, B, and C. You can't pull off the values for A, B, and C until you have the equation set equal to 0. All right. So in this case, the coefficient on the x squared term is 1. There's no number there, so it's an implied factor of 1. The coefficient on the x term is a negative 6, and the last term is a positive 8, so C is equal to 8. So we have our values for A, B, and C, so we're just going to plug those into the quadratic formula. I'm going to go through this part relatively quickly because this is just something that you have to just put pencil to paper to practice. But notice that I have a negative b here. Well, my value for b was negative 6, so I hold the negative sign outside of b and drop b inside. So this is going to be the opposite of negative 6, so when we simplify that, that turns into a positive 6. So be careful with things like that. The b squared term comes up again, first in the radical. Then we subtract 4 times the value for a times c, which was 8. Then when we do that math, negative 6 squared is 36. 4 times 1 times 8 will give us 32, so it's minus 32. This parentheses should be removed. I apologize for that. Then on the next slide, we've got that stated in a cleaner fashion. Now we can go ahead and do this subtraction underneath the radical sign. So I get 6 plus or minus the square root of 4 over 2. Well, at this point, we can then change this into 6 plus or minus 2 over 2 because the square root of 4 is 2. So since the square root of 4 is 2, we make that change in the next line. So now we're partway to our answer. All right, since this equation includes a plus or minus sign right here, there are 2 solutions. I need to evaluate x squared equals 6 plus 2 over 2 and x equals 6 minus 2 over 2. So if I do this, I'm going to end up with 8 over 2, which is 4. And when I do this side, I'll end up with 4 over 2, which is 2. So I have x equals 4 and x equals 2. So the roots of the quadratic equation, the equation listed across the bottom, which is the one we started with at the top, the roots of this quadratic are 2, 0, and 4, 0. Okay, let's try another example. All right, so this is another one that we need to rearrange. We're going to add 5x to both sides, and we're going to subtract 3 from both sides. So it turns into the equation that you see on your screen now. Now it's in the correct ax squared plus bx plus c equals 0 format. So that means that we can go through and we can pull out the one value that's implied for a. Then 5 will be our value for b, and c is negative 3. So a is 1, b is 5, c is negative 3. Now that we have those pulled out, and we always want to list those specifically, and then start with the quadratic equation and drop those values in. So there are the values that we're going to drop in. So I dropped the 5 in first with the negative sign in front of it. Then inside the radical sign, I use 5 again and square it. Subtract from that 4 times 1 times negative 3. When I do that math, I get the equation at the bottom. Then when I've completed all of the addition and subtraction, I get that x is equal to negative 5 plus or minus the square root of 37 divided by 2. That can't be reduced any further. That number is as simplified as it can be. So that's good. That means that I can divide it into its two solutions. I divide it into the two solutions since there's a plus or a minus sign. So I have x equals negative 5 plus square root of 37 over 2, and x equals negative 5 minus 37 over minus square root of 37 over 2. So the roots of this quadratic for the equation listed right here above the cursor are the two that are listed in black. So when I put those into the x comma y format, I get the two roots that are shown there. Those are pretty gnarly, but they're correct. You won't get a whole lot like that, but you could run across some that are that complicated. Generally, they're not, though. Okay, now let's remember that when we solve these quadratic equations, we can get something that looks like this, and the square root of 28 is the product of a perfect square. So I can factor 4 out of 28. So 4 times 7 is 28. So if I reduce the square root of 28, that reduces to 2 times the square root of 7. So if I get this sort of an answer, then you need to go through the process of simplifying this radical so that then your final answer would become negative 2 plus or minus 2 times the square root of 7, all divided by 3. The other two examples on this page are the same sort of thing, where we have a radical that is the multiple of a perfect square. So we had to reduce it so that we have a format that is more consistent with math rules. So now you're going to take a little bit of time to practice the quadratic formula. There'll be a little quiz that you need to take on that when you come to class next time as well. Thank you.